Hello, and I know we have a long presentation with a lot of good information, so we'll get started on time. Our presenter today is Andy Duncan, who's a part-time energy training coordinator at Lakes Region Community College in Laconia, New Hampshire. He manages the college's Building Performance Institute, Building Analyst Energy Auditor Training Program, as well as the Building Operator Certificate Program for commercial facility professionals. He also manages the USDA-funded New Hampshire Rural Renewables Technical Assistance Program for New Hampshire rural small businesses. In addition to his work at the community college, Andy provides independent sustainable energy program management and training services through his business, Foster Sustainable Energy, LLC. Andy has over 25 years of experience in clean energy projects and education, previously co-owned a New Hampshire building energy performance company. He has a PhD from the University of Michigan School for Environment and Sustainability. We're lucky to have Andy with us, and he has agreed to shorten this presentation to a 1-hour session. We will share with anyone who registered the recording and the abbreviated version and the long version of the slides in a follow-up. I will also put them in chat, and I ask that throughout the presentation, if you have a question that can be addressed quickly, to please put it in the chat, or if you need a clarification. We will have 5 minutes for Q&A at the end, but during the presentation, feel free to include any of your questions in the chat, and I'll hand it over to Andy.
Thank you very much, Sina, and great to be here. I really appreciate all the excellent work that New Hampshire Businesses for Social Responsibility does. And sounds like you've got neat energy challenges and things like that. And so whether you're in here with me right in this hour or listening to this as a recording, great to have you with us. And this is a button-up presentation. As Sina mentioned, it's a shorter one than usual. It's sponsored by NHSaves, which is the group of 4 utilities, Eversource, Liberty, New Hampshire Electric Co-op, and Unitil, that have gotten together to offer a variety of different programs and incentives associated with energy efficiency with their electricity and natural gas programs. And so we're going to cover just how to improve energy efficiency in your home. And we are going to cover kind of some basic energy use and savings tips, get into a little bit of detail about insulation and air sealing and ABCs there. And then I'll also talk about what to do. New Hampshire Saves programs. I've got a couple slides right at the end that I've recently added about the Inflation Reduction Act, because they have some programs, the federal law that got passed last August, that are pretty relevant to the sort of things that I'll be talking about. So hopefully we will have time to get to that right at the end, and maybe a couple minutes for any other questions that you have right before the 1 o'clock hour. And I think you know already, but if you want to get a full version of the slides, the 1.5-hour version, it's available from the Plymouth Area Renewable Energy Initiative, plymouthenergy.org. You can just do Parade Button Up web search, and this link will come up. So a question that, because we're doing this pretty quickly, I'm going to answer it, but I want you at least to kind of ponder it, which is, what is the greenest energy? Is it solar? Is it wind? Is it hydro? Is it nuclear? Well, at least in my opinion, and a lot of other experts, the greenest energy is the energy that you don't use. In other words, negawatts, as Amory Lovins coined the term way back when. And that is really what we're talking about, is energy efficiency. It also includes things like energy conservation. And I'll talk a little bit about that kind of behavior changes. But the emphasis today is going to be on energy efficiency. And I think that the best way to kind of start with that in your own home is just getting a handle on how much energy you do use, looking at your electric bill a little more closely than maybe normal, and potentially measuring energy use, and just understanding that some of the major energy uses might be things that you don't plug in. But there's a good number of things that you do plug in that use a lot of electricity. And this is just a kind of a quick table of thinking about the typical types of electricity use in a home, and the number of kilowatt hours, which is what your electric bill comes in, how much is being used in a typical home over the course of a year. And then the stars over on the right are kind of give you at least a rough idea where some potential savings are possible. And so not everybody has an electric water heater, for example. Some people might have a gas or oil water heater, so not as relevant for some folks. But most all of us have refrigerators, and certainly newer ones are going to be a lot more efficient than older ones. And so I'll talk a little bit about some of these other ones as well. But as I mentioned, I'm going to be kind of going through the slides pretty quickly. So if you're wondering, well, how much electricity is being used in my house? One easy way to kind of go after that, say for your refrigerator, or for other appliances that are plug-in, is you can get these plug-in watt meters. They're available also for on loan with a lot of New Hampshire public libraries. And they're going to measure how much electricity is being used by those individual plug-in items. And you can look at it in terms of, they'll also have a timer with it. So you can do a little algebra to figure out how much would this refrigerator, if I have it plugged in for a day, be using over the course of a year. And that's kind of the helpful sort of numbers is to think about. If you want to get a little more sophisticated than that, there are whole house electricity monitors. Sense is one brand, and they'll basically give you an idea of your kind of second by second consumption of electricity. And some of them can also differentiate different either circuits or individual uses. I think they're pretty nifty. A little bit more of an energy geek than most folks, but if you feel like you need a little more information about how much electricity is being used, it's about $300, $400 to install one of these. So it's not super cheap, but I would encourage you to look into it. And so in terms of kind of that idea of conservation, it's as simple as shutting things off when they're not in use, particularly lights and things like that. I like to say that it's the people who aren't listening to this presentation are the ones that probably need to hear that message more than the ones who are. But it's helpful to kind of at least have that ethic of saying, okay, if there's a way to turn off a room light that's not being used, let's try to do that. And then some other conservation type tips, they're kind of more on the behavior side of things, is just turning down your hot water heater to kind of barely hot enough that you could stand it coming out of the tap, which is about 120 degrees. And if you have, say, a dehumidifier in your basement, setting it so that it's not at too low of a humidity setting, so it's running all the time, just enough, which might be 60 or 70% humidity. So it's not running all the time and using a lot of electricity, but running just enough. And things like washing clothes in cold water, line dry clothes outside, if you can do that. Those are other sort of behavioral type things that you can do that will cut down on energy use. And certainly one of the big opportunities, kind of more on the efficiency side, is replacing older style light bulbs and lighting with LED light bulbs. We've already made a lot of progress. A lot of homes already have LED lights. I would encourage you to kind of scour your home and yard for opportunities. Anything that's on for, say, more than a half an hour on average a day, probably would make sense to convert it from an old incandescent high wattage light bulb to a lot of these LED light bulbs are only using 10 watts or less. And there's a lot of different opportunities. You do want to kind of take a close look at the packaging and the suitability. Light color is one thing to kind of pay attention to, that some lights are kind of more bluish, other lights are more yellowish. We in the US are used to kind of a warm white, which is the technical term for that is it's a 2700 Kelvin light temperature. and that should show up on the package. And certainly if people have questions about lighting, I'd be glad to take them, but I'm not going to go through all the details here. But just the big point here is that if you do have old incandescent light bulbs, 60, 75, 100 watts, and you're using them at all in your home or in your yard, it makes sense to change them out for LEDs. And then some other energy efficiency tips. We're kind of still at that point of just sort of talking about sort of quick tips. Things like low flow shower heads and faucet aerators, save not only on water consumption, but also on the fuel used to heat hot water. And a nice do-it-yourself kind of weekend activity would be insulating any uninsulated hot water pipes. That could be both for your heating system if you have a boiler that heats hot water to heat your home, or your hot water heater for domestic hot water. And as I mentioned before, setting dehumidifiers at the right setting and using things like Energy Star labeled appliances and electronics that use less electricity than the ones that aren't Energy Star labeled. And along those lines, there are some rebates that are available from the New Hampshire Saves program through all 4 utilities. They vary a little bit because some of these appliances are more efficient than others. And so you'll get a higher rebate for some of the more efficient ones. And these are just, there's some other ones besides the ones listed here. And you can go to NHSaves.com and look this up and see what the particular application process is. For a lot of these, you can apply for a rebate online, or you can also send it in the mail. And then a pretty neat program that the electric utilities offer is a free haul away of an old operating refrigerator or freezer. And they'll not only take it away for free, but they'll give you $50. And this is where I tend to tell folks of like, my electric utility that's trying to sell me electricity is going to take away an old refrigerator that's using electricity and giving me $50. It's like, whoa. And the reason why is because this is the energy efficiency side of the electric utilities, and they're trying to come up with ways to cost effectively have us all use less electricity, less natural gas. And so this is, for say an old refrigerator that is still functional, but doesn't really have much of anything in it. They don't want to have you get rid of your main refrigerator. They want to have you get rid of your second or third refrigerator or freezer. So a very cost-effective way to reduce electrical consumption and for you folks to save on your electric bills. So I want to move from kind of those quick tips, talking more about electrical consumption and what we call base load energy use that could be with different types of fuels, and move into staying warm in your home, which now is the exact wrong time to be talking about that. But thanks for bearing with me. And it's certainly a big part of your fuel bill and energy bill altogether is heating your home in the wintertime. But yes, it's mid-April. We're thinking more about spring and summer, but helps to at least be kind of preparing for next winter and future winters. And any questions that want to cover from you folks? I'll assume we're good.
Yep, nothing in the chat yet.
Okay. So, the goal here in the wintertime, come October, November, and the rest of the winter months that we want to forget about now, is using less energy and still staying warm and comfortable in our home. So yes, we can turn down the thermostats, but there's other ways beyond that we can use less energy and be comfortable. And I think what a lot of people don't realize who haven't had what we call weatherization work in their home is how much more comfortable their home becomes after they get air sealing and insulation and other work like that. And so to kind of get us ready to talk about all that, it's important to understand, and we're not going to go into great detail here, that heat can escape out of your home in the wintertime. And certainly it moves any time of year through 3 different methods. Conduction, which is through materials. So that hot poker stick in the fire, you certainly feel if it was metal and conducting heat, or convection, which the easiest way to think about that is air movement and air leakage in a home. And then radiation, what we're really talking about there is feeling warm from a fire on a cold day, or feeling warm from the heat of the sun, the radiated heat of the sun. So we're mainly going to talk about conduction and convection here, and we want to slow down that process of heat escaping out of a home. And so since conduction is one of those processes, the way that we slow it down is with insulation. And the way that we measure the insulating value of materials, insulation types, is R value. And so I'm not going to go over all this list here, but a lot of materials that are insulating materials have R values on the order of like 3 or 4 or 6 per inch. So R6 per inch means that it's pretty good insulating material. I will point out that a new double pane window is probably around a R3.5. So you can think about that window, even, a brand new Energy Star window, maybe it's R4. It's going to have on the order of insulating value about 1 inch of insulation. And most homes have a lot more than 1 inch of insulation in their walls, in their attic, and hopefully in their basement as well. So don't think of, even though it's Energy Star, don't think of those windows as being, really awesome insulation wise. Think of them really just the opposite, that they're what we call thermal bridges. They're where, particularly at nighttime, in the wintertime, where there's a fair amount of heat conducting out from those windows. And I'll talk a little bit more about windows later on. In the same way with wood, wood is not a great insulator. It's not horrible, but certainly anything that's made out of masonry type materials or stone materials, concrete, bricks, stone, very poor insulator. So if you have any exposed materials like that, say in a basement wall, there's a lot of heat typically that is conducting out through that wall in the wintertime, and something maybe to kind of pay attention to and get improved upon. And so if we're thinking again, kind of that whole conduction insulation concept, there's certainly plenty of ways where insulation can be insufficient, and the picture over on the left, or incomplete, where that wood that's exposed in the attic is conducting more heat than the areas that have the batt type insulation that you see in the middle picture, or misaligned, where nice insulation job up in the attic, but they're essentially insulating the outside to outside because they have a louvered vent that vents that cold air from outside in the wintertime. So not the best situation. They would want to close up that louvered vent and put in insulation to cover it up. And so that's on the conduction side of things. I want to move to the convection side of how heat can escape from a home in the wintertime. And certainly all these concepts are relevant in the summertime as well. They just are a little bit different sort of dynamics. And so I'm mostly focusing on where we spend the most amount of our energy dollars in New Hampshire, which is keeping homes warm in the wintertime. And so particularly in the wintertime, what will happen with a typical house is that cold air leaks in through cracks down low in the house and warm air leaks out. We call that air leakage. And the general principle of sort of like the hot air balloon effect in a home is called the stack effect. And so it's just the fact that warm air is a little bit more buoyant, like a hot air balloon, than cold air, and cold air is a little bit more dense. And you can have that same sort of convection effect happening within a room. And so the graphic at the lower part of the slide is showing a wood stove inside a house, and how if you were an energy geek like me, to go around with like a little piece of tissue in the wintertime or even in the summertime and see where there's little kind of slight currents of air that might be in a doorway or stairwell or near a heat source like a wood stove. And so the air gets warm, but then it gets cooled by windows or other things that might be not as good at insulators. And so we have that type of movement that can happen within a house as well as the air movement from outside to inside or inside to outside. And so here's another graphic that kind of shows a little bit more detail, areas of what we call air leakage. And you can see the red areas up high, that's the warm air that's leaking out. So there's a lot of potential kind of cracks and spaces. And we're really not talking about very big cracks, it could be an 1/8 of an inch crack or a small hole associated with electrical line going into the house from the attic. Because really what's happening here, it's not so much coverage of an area as it is pressure differences. And the fact that there is a pressure difference between the upper portion of the house and the attic means that that warm air, that expensive air that we're paying a lot to heat, is leaking out of the house in the wintertime in particular. And then cold air is coming in to replace it down low in the house. And so a really good way to think about priorities with really air sealing as well as with insulation is A, B, and C, A, B, C. In other words, the highest priority is up in the attic. The next highest priority is down in the basement. And really the center of the house, there's just not as much going on, or really not as many opportunities, both in terms of air leakage as well as air sealing, which is sealing up those leaks. And the same thing can pretty much be said with insulation. ABC, attic, basement, and center makes sense as priorities for insulation as well, partly because it's just easier to add insulation up in the attic. So just a couple examples here of looking at air leaks. This is up in the attic. You'll see that some of the insulation is darkened. And the reason why it's darkened is because dust is coming up and getting caught in that fiberglass material. So we call fiberglass filter glass. It's not really stopping the air leakage. It might be filtering out the dust in the air, but not really stopping the air leakage. And so really, it's these little tiny cracks in this middle lower photo and this little hole associated with electrical wires that is causing that air leakage. It's not a huge area, but there's a lot of linear feet of those cracks. In the lower right, I call the area around the chimney kind of more of a super highway for air leakage. A couple inch gap means a lot of air leakage. So just kind of safe to say that there's a lot of air leakage potential areas up in the attic. It varies a bit on how well the house is built and whether they paid attention to this when it was first built. But there's a lot of opportunities in many attics in New Hampshire homes to do to kind of keep that expensive air in the home and do air sealing. So along these lines, kind of a rhetorical question for you folks: pegboard attic hatch. So attic hatch with a bunch of holes in it, but it's got 16 inches of fiberglass insulation on top. Is that a good thing or not such a good thing? And we've done this in the past. That's like a little Zoom poll, but for the sake of time, I'm not going to do it. Not such a great thing. The 16 inches of insulation, yeah, that's great. But the problem is that the 16 inches of fiberglass insulation isn't going to stop a bunch of air leaking through all those holes in that pegboard attic hatch. So not so great. You need to, what I like to tell people is that you need to have like these two different nodes in your head, kind of the air sealing node and the insulation node. And you need to kind of fulfill both of those in a house so that it's well buttoned up, particularly in the wintertime. And then a lot of the things that we're talking about, particularly to some extent, air sealing and particularly insulation, will help keep a house cool in the summertime as well. So even though I'm mostly talking about wintertime and keeping a house warm, a lot of this is also beneficial in the summertime as well. So that A, B, and C, some opportunities down in the basement. The graphic that says, why not this? Well, that's kind of that fibrous insulation that isn't really doing much in terms of air sealing. So that would be okay if it was well installed and there was air sealing first, but just by itself, it's not really doing a whole lot. So there's opportunities down there as well. I'm not going to go into detail, but after the attic, basement's the second priority. And then the center of the house, not as many opportunities. There is houses that have fireplaces. A lot of times those flues can be quite leaky because don't have a very good flue damper. And so there's opportunities there. Sometimes exterior doors, if you can see daylight around them, that would mean probably some air leakage around that. If you have old pulley hung windows, those tend to be pretty leaky because of all the what we call the pulley pockets. A lot of windows don't leak as much air as what people think they do. And that the best way to test that is with a blower door, which actually measures air leakage. And I'll talk about that in just a little bit. So, I've been talking about air leakage and how we can seal up houses to make them more efficient. And it's true, most homes leak too much of this expensive air. And so we want to control air leakage. And then some people talk about a house needs to breathe. I really don't think that's the right phrase to use. I think seal tight and ventilate right is a better phrase. In other words, try to get a house as air sealed as possible and then use mechanisms. Could be as simple as a bath fan or could be as sophisticated as this device over on the right, heat recovery ventilator, to basically meter in the correct amount of fresh air. So you have very comfortable conditions, the right amount of fresh air, but not too much. And there's also really good ways to control that fresh air. So I'm not going to go into detail there. And then it's important to keep in mind that we want to make sure that we don't have any moisture problems in the home. It could be like a dirt crawl space that is actually evaporating pints or quarts, multiple quarts of water a day into a house, or even things like humidifiers that might be purposefully humidifying a house, but then you have to ask, where's all this moisture going? Could it be causing condensation problems up in the attic, things like that? And so it's very important to control that moisture with things like bath fans and clothes dryer vents and kitchen vent hoods, things like that. So another question for you. What's the biggest factor causing ice dams on this house? And this is a very severe form of ice dams. Usually this past winter was not a big ice dam winter, and this was clearly a big problem for this house. Well, the biggest factor causing ice dams in this house wasn't so much lack of insulation. It was the fact that the attic was very poorly air sealed from the condition, the heated portion of the house. And so there's a lot of warm air that got up into the attic and melted the snow, caused liquid water to roll down the roof and then freeze again at the edge of the roof. And when it's this severe, it can actually get into exterior walls and cause all sorts of damage as well. This is, a huge problem. And the thing that I think a lot of people don't understand is that if a home is built to current structural code or past 30 or 40 years, you can have 3 or 4 feet of snow sitting on that house. So a house without any icicles is a very good house in the sense of being weatherized, being air sealed and insulated properly. So is this the way we solve it? Roof melt tablets, a quote unquote safe and easy way to get rid of damaging ice dams on your roof. Well, it's sort of like saying you have a headache and it's a chronic headache, and the way to solve it is to take aspirin. It's like, well, it might reduce the ice dams, but it doesn't really solve your problem. And so really to solve the problem, I would strongly recommend working with experts and starting with an energy audit or some other type of assessment that an expert, a qualified expert, is able to determine what's going on. And I think a really good way to tell whether you're working with an expert or not, besides things like their references and what sort of reports they produce, is what sort of tests are they going to be doing with the house. If they're kind of walking around, just looking around, that's fine. And that, it's a lot that can be determined, but things like a combustion safety test of your combustion devices, fossil fuel powered devices, and a blower door test and using an infrared camera all would come in very handy. And I think of all the tools, probably it's a blower door that's probably the most important tool for a home energy performance person to have. It measures air leakage, and that is hard to determine otherwise. and you get essentially a value in CFM 50 cubic feet per minute at a 50 Pascal pressure difference between inside and outside. And then it also can be used by weatherization installers to make sure that they're doing air sealing properly, what we call blower door guided air sealing. And essentially, it's just a blower door. It's just a big exhaust fan that goes into a kind of temporary expandable panel in the exterior door. And essentially, we just kind of turn up that exhaust fan till we reach that pressure difference, that standard pressure difference, and then measure the cubic feet per minute of air blowing through that fan. So very important tool. It would be one of the first questions I would ask a home performance contractor is, do you use a blower door associated with your work? And then another helpful tool is the infrared camera. And it can sort of, it's basically a thermal camera. Its pixels are, think of them, a thermal camera as being like 10,000 or 50,000 little spot thermometers. And so what you're seeing with the images there are the different temperatures of different parts of a wall. And so that one in the upper right that shows the home, our visual image is just a nice wall with a home sign on it. The thermal image shows one cavity of that wall uninsulated, the more purple one, and another cavity, at least a little bit better shape than the purple one, kind of more orangish. And the same sort of thing, lower left, you're seeing kind of a detail in a house that was not insulated. And that's pretty common. The more complex a home is with little nooks and crannies and roof lines and things like that, the more likely there's going to be spots that got missed or didn't get done well enough. And that's where infrared camera can come in very handy. It's better to use infrared camera during the wintertime. That can be used other times of year, but it's helpful having a temperature difference. Lower door pretty much can be used all year round. And so let's say that you've got an assessment, they're recommending doing air sealing and insulation up in the attic. This would be the type of material that typically is added by home performance contractors after air sealing. So first they're going to kind of uncover any sort of insulation and air seal that attic plane. And then blowing this type of material, this is a recycled ground up newsprint. It then kind of envelops the whole attic. So it does a really good job of insulating the whole thing without any thermal bridges. And it's quite a bit of insulation that makes sense up there, maybe up to about 16 inches of insulation depth in the attic. And this is examples of air sealing prior to that insulation. So what you see on the right is like a spray foam, what we call skim coat of spray foam. It insulates, but its primary purpose in this example is to make sure that all the little cracks from, say, a lath in plaster old home ceiling are now being sealed by that spray polyurethane foam. And then this is an example on the left of using fireproof materials to do air sealing around a chimney chase. And then just some more examples of attic air sealing and insulation. So people might have storage up in the attic. It's better to just have it all kind of that fluffy cellulose, the upper left, but kind of a compromise measure where some part has less insulation and storage, another part has that insulation dam and 16 inches of cellulose. And not super obvious with the lower left photo, but that is a spray foam that's on a knee wall slope. And then the white material that you see is actually what's called an intumescent paint, which is a fire barrier because spray foam is flammable. Even though it has flame retardants added to it, you want to have some sort of fire barrier, and that's important for fire codes and all. And the photo on the right shows a pull down stairs with what we call a thermodome over it, which is plywood and foam board, oftentimes multiple layers of foam board. So it's basically acting to air seal, and there's weather stripping as well. So it's acting to air seal as well as insulate. And that's really important with pull down stairs that tend to have a lot of air leakage associated with them. And then kind of that was the A of the A, B, and C. So down in the basement, on the right, photo of spray foam with intumescent paint covering it, going at least partly down the wall, using a particular type of foam board called Thermax that's rated for being exposed in the basement. It's the upper left. And an example of a basement door, bulkhead door that gets a plywood and foam board and weather strip treatment to reduce both air leakage as well as insulate that area. And then in the center of the house, there are chimney flue blockers you can buy or can be built. There's things like exterior door Q-line, weather stripping, and this photo on the right, somewhat unusual, but example of doing some air sealing in the center part of a home. And particularly for walls that don't have enough insulation or aren't insulated at all, what's called dense pack insulation can help both with air sealing as well as insulating a wall, because walls can have actually a fair amount, exterior walls can have a fair amount of air movement in them. So it's important to pay attention, to both those things, an exterior wall, the air sealing aspect as well as the insulating aspect. And this is basically that same cellulose that's fluffy up in the attic that's about twice as densely packed in a wall to help reduce air leakage and also provide insulation. So windows, like I said.
Before we move on to windows, can you address one of the questions that came in was if there's a bungalow style home, would it be effective to do it yourself and fill the walls with loose insulation? Is that a good approach?
Yeah, that's a good question. It's hard for me to answer specifically without knowing kind of more context. And if we had time at the end, glad to kind of talk with the person. But if the bungalow style home has some sloped areas, that may make more sense to have dense pack there. It's also important to be thinking about moisture control with those areas. So it kind of depends, but I would say generally speaking, a do-it-yourself insulation project would be kind of more the loose fill type, and that would be more kind of a flat attic after doing air sealing. And then as soon as you start getting into the vertical walls or the sloped walls, that might make more sense to get a professional involved who has the right equipment and can do the dense packing and other prep that might be needed.
Thank you.
So keep on going here.
Yes.
So windows, just keep in mind that, like I said, there's somewhat of weak links thermally, even a newer one. And certainly if you have like an old single pane window, replacing it with a R4, that's much higher insulating value compared to that single pane window, that could make sense. It's going to be expensive. And so kind of your bang for the buck is not going to be as much as other things that I've been talking about. And so it's one of the reasons why, for example, the utility program that I'll be talking about in just a minute doesn't help pay for new windows, because it's just not as cost-effective use of their what we call system benefit charge dollars to pay for window replacements. Yes, there's energy savings, but there's also a large cost to install new windows. And so if you're looking for less expensive options to reduce that energy loss, it's things like there's interior storms, there's cellular shades, there's window quilts, things like that might make more sense in keeping your old window. And certainly measuring overall air leakage, including with windows with a blower door test, would make a lot of sense too. And then we're not going to talk a lot about heating systems. We're mostly going to be talking about here what we call kind of building envelope improvements. But certainly there's options for heating system replacements going towards heat pumps, and I'll mention that in just a minute. And then it's a good idea if you've got a combustion type system to have it combustion safety tested. And that would be part of the energy audit that's with this home performance with Energy Star program that is associated with NHSaves that I'll mention in just a bit. And if you have ductwork, so you have a furnace rather than a boiler, sealing and insulating that ductwork, and looking at options for replacing the older, less efficient heating systems with more efficient ones. And so kind of moving into the third part of this presentation, I want to briefly talk about New Hampshire Saves rebates and services, and really emphasize this one that's, if you go to the NHSaves.com, it's under the energy audits and weatherization section, and it's called Home Performance with Energy Star. And some very nice incentives are available for the work that I've been talking about with this through that program. But before I get there, I do want to mention that there are a number of incentives available for, say, if you have a natural gas with Liberty Utilities or Unitil gas, you can get some incentives for high efficiency gas boilers or furnaces. And then all the ones that have IRA listed to them means that there's also some tax credits potentially available to you for as incentives. And so, for example, a mini split cold climate heat pump, you can both get an incentive from New Hampshire Saves as well as from a tax credit via the Inflation Reduction Act. Same thing for heat pump electric hot water heaters. Pretty sizable incentive from Inflation Reduction Act and a good size incentive from New Hampshire Saves. So that's just the same sort of heat pump concept as a mini split, but it's used for heating domestic hot water. And a lot of people don't know that there's also a nice 30% tax credit for EPA certified, so cleaner wood and pellet stoves. And so down in the lower part of the slide, I just want to emphasize that, a lot of times people kind of tend to fixate on equipment, heating equipment or other things like that. And yes, those are important to have efficient heating equipment. But if I were looking at a house that was inefficient, I would tend to recommend getting that building envelope fixed first before going after more efficient heating equipment. Because you can have an efficient heating system in an inefficient house, and you're still wasting a lot of heating energy. But if you had a somewhat inefficient heating system in a very efficient house, it might not be coming on all that much. So, you can be actually saving more energy with a situation like that than a efficient heating system in an inefficient house. And so, yes, heat pumps were kind of, with the Inflation Reduction Act and the technology changing, we're kind of moving into a new era where pretty soon there's going to be heat pump options for kind of all sorts of what we now kind of assume we have to burn some sort of fossil fuel for. We're not quite at that point yet for, like, say, a boiler replacement, but we're at the point where now heat pumps can comfortably heat a home even at 0 degrees or -10 degrees. So it's no longer that kind of, heat pumps aren't that great when it gets really cold. The technology has certainly moved along that we are at that point now that if I were building a new house, I would just basically put in a heat pump system and maybe a clean wood stove. And then, as I mentioned, the heat pump hot water heaters, I think it's a great option. If you've got fossil fuel or other inefficient way of heating hot water, they're very much more efficient, and there's some great incentives both through the federal tax credits as well as through New Hampshire Saves. So I want to emphasize home performance with Energy Star here because not only does it kind of cover a lot of things that I've been talking about, but the incentive is very impressive. If your home qualifies, the utilities will pay for 75% of the eligible energy improvements up to a utility contribution of $6,000. So that's pretty impressive. And they can also help out with low or no interest financing for the copay that you would still be paying. And then the other nice thing about this program is that you will get a pretty comprehensive home energy audit. It costs you $100 up front, but the net cost is really zero because that $100 becomes a credit towards your copay for any work that gets done. So that's the one that's through the energy audits and weatherization page. And the way that you qualify for this program is you go to that webpage on NHSaves.com, and you pretty much going to enter in your zip code, your utility, the square foot, heated square footage of your home. And the hardest part is quantifiable numbers of what you're using in terms of fuels to heat your home. So in this example, it's 800 gallons of heating oil plus 2 full cords of wood for a 2,000 square foot home in Laconia. And it basically calculates what's called a home heating index number. And if you have a high enough number, which basically means kind of BTUs of heating fuels per square foot, and you can substantiate that number through at least 12 months of heating fuel records, then you can qualify for that home performance with Energy Star program. And these are the numbers down below. It varies a little bit with utility. Certainly it's the lower numbers that are easier to qualify and the larger numbers harder to qualify. And if your home doesn't qualify for this home performance with Energy Star program using this home heating index, then you can get kind of a little bit of a consolation prize if you go through this process and it doesn't qualify. And that consolation prize is called the visual audit program, where a technician will come out and install, if you'd like, a little bit of pipe insulation, some potentially low flow aerators and shower heads, a couple couple LED light bulbs, and potentially a Nest smart thermostat, all at no cost for you. But that's certainly not as comprehensive a program as the whole home performance with Energy Star program. So that's the one really to try to qualify for if you can. And this might be a little hard to read, but it's kind of showing you some of the typical improvements that this is from an actual home that got this home performance with Energy Star program. And they got essentially $10,000 in work. It was, they maxed out that $6,000 contribution, but they only had to pay for $10,000 in work. They only had to pay a little more than $4,000. And my guess is that the payback period is probably even better than what's shown here. And this was back when fuel costs were a little bit less as well. So I also want to point out that there's very similar program in terms of the type of work it's done. The different qualification is income qualification. And that's the Weatherization Assistance Program combined with the Utility Home Energy Assistance Program. And there they'll do all that air sealing, insulation, other work at no cost to the occupants if they are income qualified. And it's typically those same people can also be on electric and fuel assistance to help subsidize the cost of their fuel bills and electric bills. So we're getting pretty close to 1 o'clock. Are there any questions, Zena?
Not in the chat. Please put any questions that you have in the chat. And
okay,
we have a 5
so
minutes after these 3 slides to answer any questions.
Yeah. So the good news is we got enough time here. I kind of whipped through the slides pretty quickly. We have enough time to talk a little bit about the Inflation Reduction Act and the fact that there's some incentives. 3 different kind of major programs through the Inflation Reduction Act. I mean, there's all sorts of programs in the Inflation Reduction Act, but the 3 ones that are most important for homeowners are I've got 3 slides. So the first one is this 25C Energy Efficient Home Improvement Tax Credit. That is available now. You'd be claiming it in 2024 for your 2023 taxes. A tax credit basically reduces your tax bill. And if you have more tax credit than your tax bill, then it is you can carry forward it into future years. So essentially, think of these numbers as the same as like a rebate. It's just a tax credit. And so let's just say that you're getting weatherization work done through New Hampshire Saves Home Performance with Energy Star. In addition to any incentives from them, you could also get a $1,200 incentive through this tax credit. There's still some details to be worked out about, what qualifies. But same sort of thing with the energy audit. If you're paying a market price for energy audit, which might be $500 or so, you could at least get a $150 tax credit. So these are the maximum amounts that you can get, and it's if it's your cost is let's just say you only spend $1,000 for weatherization, then you'd only be able to get a $300 tax credit because it's a 30% tax credit. So that's a program that's available now starting in January 2023. These other two programs, and I'll just quickly show you that there's the HEEHR program, Home Efficiency Electrification Rebate. And then there's the Home Efficiency Rebates Homes program. So let me first go into the HEEHR program. Both of these programs are rebate programs, so you would be getting rebates up front. But both these programs have not been set up yet, and they'll probably be available through the New Hampshire Department of Energy. That's who's going to be setting it up as the state energy agency for New Hampshire. Probably, you probably start hearing about it maybe in the last quarter of 2023. Probably not available in terms of the rebates themselves until sometime early 2024 is kind of the best guess at this point. This one, the home electrification rebates, it does include some incentives for weatherization, but it's kind of more geared towards heat pumps and improving the wiring or your electric panel, getting a induction electric range or a heat pump dryer or heat pump hot water heater. So it's very kind of electrification oriented. It's also income limited. So it's only available for people and families that have 150% or less of the area median income. And I think for a family of four, it's a fairly high number. I think it's like $180,000 or something like that per year in New Hampshire. So if you're under 80% of area median income, it's 100% rebates, and up to these limits here. And if you're between 80 and 150% of area median income, it's 50% rebates. So if, like, for example, a heat pump, the maximum you could get would be $4,000. Heat pump, for the most part, is going to cost more than $8,000. So even though you see 100%, it may mean that there's still some out-of-pocket costs, but it's still, for a small heat pump installation, $8,000 would kind of go a long ways. For a large, 2,500 square foot house that you want to have multiple heat pump heads, it might be $25,000 for that installation. So, it could vary a whole lot. Any questions about the home electrification rebates or the home improvement tax credits?
There's a lot of rebates and programs that you're listing. And one question is, do you have a flyer that you can easily share with all these opportunities? And is it available in multiple languages?
Yeah, that's a great question. Senator Jean Shaheen's office put out a kind of guide to the Inflation Reduction Act for homeowners. And I think her office would be a good source to ask about that. This is just kind of a couple slide add-on to the New Hampshire Saves Button Up, but it's very relevant in that pretty much all these incentives can be stacked with the New Hampshire Saves program. But there are some other good resources out there. I've got some links I could send you. There's one that's like a sort of like a calculator of like how much could you be eligible for depending on your income status and what you want to have done. And then I believe at least some of these are available in other languages. That's a good question really for New Hampshire Department of Energy. Once they get these programs going, that they're going to be producing information, and so having it in multiple languages, I think, is a great idea.
Can I ask if the heat pumps that you're talking about, do they require digging into your yard and ground to install? And is that a problem in New Hampshire with our granite? Or is that
Yes.
not an issue?
So what you're thinking of is what's called ground source or geothermal heat pump.
Yeah.
And those are installed to some extent. They're more expensive to install. And then the probably the more common, what people typically call mini split heat pumps are what officially are called air source heat pumps. And then even more important in New Hampshire is that you'd want a cold climate air source heat pump. And so those do not involve digging into the ground, because rather than taking the warmth of the ground, they are taking, and it's kind of a hard concept to wrap our heads around, they're taking 0-degree air on a cold day and essentially concentrating that 0-degree air through the refrigeration cycle and turning that into heat into a home. And so generally speaking, I'd say for 80-90% of the homes out there, the air source heat pump is going to make more sense for them. They're going to cost less. They still, these days, they perform pretty well, almost as well as a ground source heat pump. And they don't involve digging into the ground. What they do involve is sending refrigerant lines from that outdoor unit to the heads inside. So if you have multiple heads, you might have seen these on houses that kind of look a little bit like downspouts or something like that. They're about 3 inches wide or so, usually plastic material that kind of goes up and then goes into wherever that head is, where the heat or the cooling is going to be generated. And keep in mind that these heat pumps provide heat in the wintertime and air conditioning in the summertime. So there is some aesthetic concerns about it. You want to make sure that the house and its circuit panel can handle the extra load. And so that's what's nice about this program, is that there's some rebates for any electrical upgrades that might be needed. But for the most part, they don't really need to kind of get into the ground too much. And I know we're getting close to 1 o'clock, so let me make sure I cover this slide as well. This is kind of closer to the Home Performance with Energy Star program. And again, it can be stacked with Home Performance with Energy Star, or it could be standalone. It's a kind of whole home retrofit program, a little bit more emphasis on things like air sealing and insulation, but it could include other upgrades as well. And really, it's more geared towards, rather than devices and equipment and electrical upgrades, it's more on what are the savings, the overall energy savings. And so the maximum rebate, there's not an income limitation with this one. It's just the under 80% adjusted mean income or over 80% adjusted mean income. And that would determine whether somebody gets an 80% rebate or 50% rebate. But then it also is a factor of how much energy savings, either modeled or measured. And what I put in here is the modeled energy savings approach. So you can kind of see what the maximum rebate would be. But really nice that if you were to go through the New Hampshire Saves with Energy Star Home Performance with Energy Star program, that at least starting probably in 2024, you could also get some additional incentives if your energy savings are sufficient. So yeah, it's pretty complicated, all the different programs, and I know I've kind of threw a lot at you in a short amount of time, but hopefully this was helpful as at least a place to get started. And you do have the PDF of the presentation you can look at. And then this is my contact information, both through Lakes Region Community College, but also have my own consulting outfit that Zena mentioned. And it's Plymouth Area Renewable Energy Initiative that is organizing these presentations. So it's the plymouthenergy.org website for getting a copy of the full presentation.
So
thanks very much.
Thank you,
Yeah.
Andy. Thank you for the wonderful presentation with lots of resources. There's a question about leaving. A lot of people tend to do this. They leave their computer on and they have 24/7 cable internet access with routers on. Is that a big loss of energy? How do you handle that?
Yeah, it's a good question. We did have some slides in previous versions or more full versions of the presentation about what we call vampire loads. And that's things that are on but not really being used. The Energy Star appliances tend to do better with that, that if you have them turned off, they're not going to be using as much electricity. So, and things like routers, that's where it'd probably be helpful to plug it in with one of those energy electricity meters and see how much they're using. Probably not using a ton, maybe 10, 20, 30 watts, but it can also add up as well. And you can get what's called smart strips that are kind of like your typical power strip, but they have a particular outlet that, say, for example, if you have a computer system with speakers and printers and all sorts of other things, extra monitors, that if you have your main computer into that particular outlet, when you turn the computer off, everything else will go off as well. And so that can come in handy for situations like that.
And if you hire a building performance professional, are they aware of all these rebates and tax credits? Will they help you go after them, or do you still have to do your own homework and figure out?
Yeah, that's a great question. They should. It's sort of like, does your doctor know everything about your health? It's like, yeah, they, hopefully should. But, there are some kind of old school insulators that's like, oh, I'm never going to use a blower door. And, I don't want to participate in these utility programs. And so there's certainly some that aren't as knowledgeable as others. And so hopefully this presentation kind of give you a little bit of food for thought of like questions to ask. And certainly some home performance contractors see the Inflation Reduction Act as a great opportunity. So it really is kind of the whole gamut. And you do want to ask, how familiar are you, or do you participate in the home performance with Energy Star program with New Hampshire Saves, or are you prepared to participate with the Inflation Reduction Act homes programs or things like that? Particularly with the Inflation Reduction Act, those two programs that aren't set up yet, there's not going to be a whole lot of knowledge out there because the U.S. Department of Energy hasn't even put out all the rules, all the details about what these programs are going to look like. But at least we know what kind of at the level of what I presented at, that there's some kind of broad strokes of what the program's going to look like. But the tax credits, for example, those are available now.
And any questions? I know we're wrapping up. It's past the 1 hour, but Andy has we're grateful that he offered to stay for a few more minutes. So if you have questions, please include them in chat or unmute. And thank you very much, Andy, for the presentation. I'll stop the recording now and allow anyone to ask any questions after.